Let me just mention the setup for this last problem, because this now allows us to start thinking about how Lewis forms can be related with enthalpy. Once again, we're doing combustion. This combustion is for ethane, C2H6. Okay. So ethane, which is a gas, reacts with oxygen. I want to find the enthalpy change from bond dissociation energies. Combustion gives CO2 and water as the products. So to balance this reaction, we need 2 moles of CO2 and we need 3 moles of water. And now we have 3 oxygens from water. We have 4 here, so we need 7/2 mole of oxygen to get 7 on either side. And you could, of course, multiply it through to balance it further with whole numbers. Keep in mind that bonds that have to break, those are endothermic processes. You have to put energy in to break any bond, no matter how strong or weak it is. And when you form bonds, the nuclei get to share electrons, which takes them to a lower energy state. And that's exothermic, formation of bonds. So if you're not given enthalpies, but instead you're given bond dissociation energies, all positive values, because they're all the amount of energy that's required to break a bond, then you can look at the bonds formed and broken from a chemical reaction and calculate the enthalpy change. You have to draw the Lewis structure, though, to count the number of bonds. So ethane has 2 carbons, the central atoms, and 3 hydrogens on the outside. Okay, so that's 6 CH bonds. And then oxygen really looks like this, but you could draw it with a double bond if you want. We're going to have to break 7/2 oxygen-oxygen bonds. CO2 has carbon as the central atom with 2 double bonds to oxygen. And so we need to break 2 moles worth of CO2, or sorry, form that much. So there are 2 CO bonds per CO2. There are a total of 4 CO bonds that are forming. And water, of course, has oxygen as the central atom. Okay. I haven't put the lone pairs on here, but you know where they are. There are 2 on each oxygen. Now, if we're making 3 moles of water, each water has 2 OH bonds. That's 6 OH bonds formed. So these are endothermic, breaking reactant bonds, and these are exothermic. So to calculate it per mole of ethane, then what we do is the bond dissociation energies of the reactants, the amount of energy input, minus the bond dissociation energies of the products. That's exothermic. Okay, so we're not calculating delta H from enthalpy of formations this time. That's products minus reactants. Here, they're all positive values. They're bond dissociation energies. So we have to add them up after drawing the Lewis forms. And then it's reactants minus products, or endo minus exothermic. So for the 6 CH bonds, you would say 6 times the 439. And then you have 7/2 of O2. O2, that bond was 498. And then for the products, we make 4 CO bonds, 732 per CO bond, and 6 OH bonds, which are quite strong, 497. And that will give delta H reaction. So I'll sum this up. 2, 6, 3, 4. Seventeen, 4, 3, Don't forget the parentheses there. Okay, so the overall enthalpy change should be exothermic. It's combustion, releases heat, and it is negative 1.533 times 10 to the third kilojoules. So that puts everything together, right? Calculating enthalpy, but first drawing Lewis structures and recalling that bond cleavage is endothermic, requires energy input, and bond formation is exothermic.